Hello, my name is Ndejia, and today I'm gonna do my presentation on drug addiction. By the way, we're gonna study what the cellular basis of drug addiction. Introduction. Drug addiction, which despite lack of control over drug use, can be described as a compulsive finding and taking of drugs, is triggered by long-lasting drug-induced change that occur in certain brain regions. Both the distinct brain regions that are important in mediating an addiction syndrome, as well as the kind of change at the molecular and cellular level that drug induce to underlie key aspect of addiction in this region. The dopamine system, which involves dopamine neuron in the ventral tegmental area of the midbrain, innervating medium spinning neuron in the nucleus accumbens NAC, a part of ventral striatum. The dopamine receptor. Dopamine receptors are part of the superfamily of G protein coupled receptor GPCR. We have D1-like receptor and D2-like receptor based on their ligand recognition property and their effect of CMP development. D1 receptor consists of D1 and D5, whereas D3, D4, and D2 are D2-like receptor. Dopamine receptor. D1-like receptor activate GAS-OLF and stimulates the development of CMP, while D2-like receptor activate GAEO. The to 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 inhibit the activity of adenylate cyclase and the production of CMP. D1-like receptors are primarily found postsynaptically, whereas the D2-like receptors are found on dopaminergic target neuron postsynaptically and on dopamine neuron as presynaptic and autoreceptor. So now we're gonna go into the mechanism and transcriptional and epigenetic. The long-term effects of substance addiction on gene expression in the brain have been mediated by proteins that bind to regulatory region of gene and thereby increase or decrease the transcription of those genes. Prominent examples include, among others, CREB, FOSB, MEF2, and glucocorticoid receptor. The cellular signaling pathway by which abused drug trigger a given transcription factor in the brain can be progressively understood in this figure that explains how what is the pathway that the drug attend our brain. So, next slide. CMP response element binding protein. In the phase of drug addiction, it plays a role as a transcriptional regulator. The CMP pathway upregulation, which is form of a drug addiction, is facilitated by its activation in brain region essentially for addiction, including notably in the NAC, stimulant and cause drug abuse of CREB. CREB is known to be activated by CMP and CA2 and growth factor pathway in other systems, and it is not yet known which of these mediate its activation via drug abuse in NAC. Next slide. CMP response element bending. A negative feedback mechanism has been shown to reflect drug activation of CREB in NAC. CREB activities appear to include all major subtypes of NAC medium spinning neuron, those that primarily express D1 versus D2 dopamine receptor. Interestingly, a wide body of literature has shown that CREB acts in the hippocampus and amygdala. Next slide. Delta FOSB. In NAC and many other brain regions, acute exposure to nearly every abuse of drug induces all FOS family transcription factor. Among these FOS family protein, delta FOSB is a truncated FOSB gene product. It accumulates progressively over a prolonged drug exposure course and become the predominant FOS protein expressed under this condition. For nearly all drug abuse, this chronic induction of delta FOSB has been shown and is selective for G1 type NAC neuron for most drugs. As for CREB, using the candidate gene and genome width approach, numerous target genes for delta FOSB have been identified in NAC. So, dynorphin is induced by CREB, delta FOSB suppress it, which contributes to the pro-reward effect of delta FOSB. SFOS is another delta FOSB target. As delta FOSB accumulates with repeated drug exposure, it suppresses CFOS and leads to the molecular transition, selectively inducing delta FOSB in the chronic drug treated state. The ability of some drugs to induce synaptic plasticity in the NAC has been shown to mediate several other delta FOSB target and associated change in the dendritic arborization of NAC medium spiny neuron. So here are the references, and thank you.